Good morning, good afternoon, or good evening. Welcome to this webinar from Allegro Microsystems entitled Empowering the Future, Unlock the Potential of 48-Volt Systems. My name is Paul Pickering. I'm a practice leader in the semiconductor group at Omdia, part of Informa Group. We provide research that tracks market and technology trends in many different areas, including power semiconductors. And I will be acting as the moderator for this webinar. It's nice to meet everybody. Before we get started, let's go over a couple of housekeeping items. The PowerPoint and any other additional resources associated with the webinar can be downloaded in the resource widget. If your screen freezes, you're having trouble with the connection, the best option is usually just to log out and log back in, and that will refresh all the settings. There will be a Q&A session at the end of the discussion. Enter your questions in the box and we'll make time for them at the end. If you're watching this on demand after the event, your questions will automatically be emailed to Allegro and they will get back to you with answers. So let's talk a little bit about 48 volts. There are many choices as an engineer when it comes to choosing a DC bus voltage for your design. As we'll see today, 48 volts is emerging as a game changer in many fields. Let me just touch on a couple of examples. In automotive, 12 volts in a lead acid battery has been the standard since the 1950s. But more recently, as the industry transitions to electric vehicles and autonomous driving, 12 volts is no longer able to supply all of the power needs in the modern vehicle. 48 volts is the way of the future. In data centers, cooling and ventilation systems already account for up to 50% of power consumption. And as rack power densities continue to increase, driven by, in at least one case, by the explosive growth of AI applications, power architects are always searching for ways to reduce power losses. Moving to a 48-volt bus is a big part of the solution. Finally, with the rise of such applications as robotic work cells and the industrial Internet of Things, the power requirements on the factory floor are also going up. Here again, 48 volts has a key role to play. So to help us understand this, I'm pleased to welcome 4 experts from Allegro Microsystems to go over the different DC bus options and why 48 volts is becoming the preferred choice in so many applications. Ram Satapan is the Senior Director of Applications Marketing. Andrea Paletto is a Senior Member of the Technical Staff. Karsten Himmel is the Automotive Segment Marketing Manager, and Gloria Kim is the Industrial Segment Marketing Manager. Okay, so let's get started. The first question that might come to mind is, what are the different types of supply voltages typically found in different systems, specifically in the automotive and industrial applications?
All right, starting with industrial voltage levels. So when it comes to industrial electronics, there are a variety of different system level voltages. Shown here are not all, but some of the most commonly used voltage levels. These voltages can vary significantly depending on the application itself and the type of equipment that is being used. So starting with 5 volts here, 5 volts is a very crucial voltage level due to its compatibility with various components. For example, many digital components such as microcontrollers require 5 volts for operation. 12-volt power supplies are used for a broad range of devices, including sensors, actuators, and relays. 12-volt DC motors and actuators are also commonly used in industrial automation for tasks that require a moderate amount of power and torque. 24 volts has become a very standard voltage level in industrial applications as well to power sensors, actuators, PLCs, and other control devices. 24 volts offers a good mix of power efficiency and safety. 48 volts, which is our topic of the day, is utilized today in a lot of telecommunications and data centers for efficient power supply. And there is a growing need for 48 volts also for high power motors and actuators, or even power distribution units used in industrial applications that can operate a certain machinery or equipment. Now going into AC voltage ranges, this really depends on the region. So 124 volts AC is typically used in North America as our standard household and commercial voltage. It's common for small industrial electronics, control panels, and low power machinery. And then in Europe, 230 volts AC is their standard voltage for many of their electronic systems to ensure that there is efficient power supply for a wide range of appliances and equipment. So in summary, the choice of the voltage, again, depends on the industrial application, and it is specific to the equipment being used. But typically, higher voltage are used for the high power application to enhance that efficiency and reduce costs, while the lower voltages are more selected for control systems and safety critical applications to ensure a safe and reliable operation. And next, Carson will go into the automotive supply voltages.
Thank you very much, Gloria. So in an automotive context, we have quite some similarities with industrial applications. Still, we have some differences, and that main difference is that we are usually coming from a battery-operated vehicle. So we don't really have so many applications that we are now talking about. On AC, of course, there are some, but let's start with the smallest ones. And there we pretty much share everything with the industrial applications. So sensors, microcontrollers, and some other consumers are operated at 5 volt and below. Since the 1960s, we have a 12 volt automotive system, and that is used for pretty much every non-powertrain electrical consumer. Vehicles, 12 volt vehicles, and many commercial vehicles, we have 24 volts. The applications are quite similar. What is new now is we're talking about 48 volts in multi-hybrid applications. So for supporting the powertrain, we're talking about starter generators and brake energy regeneration, but also we're talking about ADAS applications, steering and braking, which are based and can be optimized in 48 volt applications. Going to the higher voltage levels, here we have it visualized as 200 to 800 volts. Typically, we're talking something about 400 and 800 and going even beyond. That's usually where you have your traction system in battery electric vehicles and also in plug-in and full hybrid vehicles. So that's a rough understanding of the voltage levels in electrified cars. And back to you, Paul. So this is pretty much a summary that we have.
Thanks, Carsten. That's interesting. I mean, you've gone over a lot of different voltages here, many of which have been used for many years, as you mentioned. So what makes 48 volts the happy medium? I mean, how does it compare, and what are its benefits compared to some of these other standard voltages that we've been talking about?
So
I'd like to take that.
Gloria has already raised it. Gloria has raised it a little bit when she was speaking about 24 volts in an industrial context. With an increase of voltage, let me show you, we have different advantages that come with it. The prime advantage is if I remain with the same current, I have an increased power that I can provide to different consumers or loads. So this can be helpful for higher power demanding applications, for systems that just require higher peak power or continuous power. But also, if we're not aiming to increase our power, we can lower the currents, which has different benefits on its own. So lower currents mean that we can also reduce our power conduction losses. And we can further reduce the harness. So by reducing the cable diameters, we are able to save some space, but also weight that we don't have to carry around, which is especially beneficial for moved objects, not necessarily only vehicles, different products. So technically we could say higher voltage allows us lower currents, and higher voltage is better. But back to you, Paul, maybe there's a limitation.
Okay, so yeah, I get it, Ohm's law being what it is, but if 48 volts is better than, let's say, 12 volts, why not higher? Why not 80 volts or 100 volts? What's the problem with that option?
I'll take that one, Paul. Thank you. So
Okay.
Thanks, Karsten, for explaining the 12 and the 48 volts. So that's a very good question, right? Why stop at 48? Why not go to 64, 96, and beyond? I think it really comes from safety. Safety is one of the main factors that stops us at around 48 with some margin, because many standards agencies like the IEC, as well as the ISO and Universal Laboratories, OSHA, employee safety and the worker safety organizations, they've all put in place standards that states that 60 volt is really the safe medium when it comes to DC voltages for humans. I know in AC we all know that when you get hold of a live AC wire, we can get a shock at 110 volt. It really comes down to 60 volts. 60 volts is a very critical, and it's also called a safe extra low voltage in the standards organizations. That voltage is kind of the limit at which humans can interact. Below that voltage, beyond that is not safe for humans. So that's one of the main reasons. So all regulations and standards require that any human handling voltages higher than 60 volt needs to have some precaution and some safety standards in place for them to be able to operate around equipment with higher voltages. And it doesn't stop just at safety as well. So now, because like I said, right, humans have to interact at higher voltages, then it requires higher amounts, more expensive insulation and isolation of those equipment, which is going to add a significant amount of cost, and it could take space, weight. It increases the complexity of the design. And then beyond that, most of the products they've been talking about have been designed for automotive direct connection to battery voltage. You've seen that. That's why many of the semiconductor components available today are designed for either 24 or 36 volts. That's what typically most of the products out there are designed for, because they are designed to connect directly to the automotive battery in automotive systems, and industrial as well. 12 and 24 volt systems can directly connect up to those supplies. But if you need products beyond that, 48 gets expensive, but beyond 48, it's going to get even more complex and expensive. So that's going to be a challenge in terms of availability of products, the choice of products that you need to complete your design. So those are some of the big concerns, but there are a few other concerns, like thermal management becomes a challenge as you go higher up in voltage. There's going to be a lot more interference in terms of noise, EMI and EMC, which now you'll have to comprehend in your design. Every one of these things only makes the design more complicated. And so 48 volt really safety drives that, because with 48 volt plus a little bit of margin, you can be safely within the 60 volt range. And that makes it the maximum throughput we can get, but still be safe. That's why we've settled on 48 volt. And just to close it out, 48 volt has a lot of challenges, but it has got a lot of benefits we've talked about. And designers do have to keep a few things in mind when they're designing with 48 volts. So some of the examples are given below at the end. Really, spacing terminals in connectors is going to be important. So you got a lot of connectors that are going between wires. We got to make sure the spacing is appropriate to prevent arcs, because those arcs happen at 12 volt, 24 volt, and 48 volt. In 48 volt, it could be more damaging. So you got to be very careful on how those electrical connectors are designed, and precautions will have to be taken care of for unwanted current flow from a lower voltage or a higher voltage system, either vice versa. So that has to be done. Make sure the system is designed properly to prevent damage to components on the system.
Okay, that's a good. The safety is a huge issue, because in my previous experience, not only do you have to isolate the power, you have to isolate all the signal level areas too, and you have to re-architect the whole system so that you keep unsafe voltages away from not only humans but also other machines. So this is a really key point, I think, why we picked 48 volts as opposed to some of these higher voltages.
That's right. You got it.
So, so talking a little bit more about 48 volts, I mean, can you talk a little bit more about some of the benefits in automotive, industrial, as we've discussed, with some examples of applications and use cases where 48 volts is clearly a superior solution? Who'd like to take that one?
Absolutely, we can do that. So let me start with the automotive applications. There, I've already spoken about it a little bit. We have two main differences. So on the one hand side, we're talking about multi-hybrid electric vehicles, and we're also talking about the integration of 48 volt on a general basis for all electric supplies or all electric loads in the vehicle. Ultimately, what we want to achieve is an improved performance and efficiency. So with these reduced currents and reduced conduction and power losses, we have a higher overall efficiency that our system enables us to design to, and that gives us further kilometers or miles and driving range. That's true for any type of vehicle. So it could be an ICE propelled, or it could also be a fully battery electric vehicle. Also, what comes with it is another important point, that's power density. So we want to make sure that the components which are used in a vehicle can be designed as minimum space demanding as possible. So that space can then again be used for something else, or it can just be saved to again improve the efficiency. And the third main point is higher power. So when we're talking about electrified vehicles, we usually have different options to improve our power. And by modernized vehicles, by more autonomous and higher automated vehicles, we're not only talking about that typical powertrain, we're also talking about the improvements of subsystems such as steering or braking. So a by-wire system has a higher potential if we can enable it to consume higher peak or continuous powers, and that's just very beneficial in 48 volt systems. But not only for safety or for autonomous driving features, we're also talking, and that goes back now to electrified vehicles, we're talking also about battery conditioning, where we have quite a big impact. So when we talk about electrified vehicles, one point that always comes with it is not only the driving distance, that I want to be able to do as many kilometers as possible. It's also about the longevity of the traction battery. And in 48 volt systems, I do have a higher power that is available for all my battery management systems. So for my thermal management, all the pumps and fans that I need to have in order to condition my battery and keep it in the right thermal spot, these systems can be dimensioned better to prevent losses on the first hand. And also by having a higher power, I have the additional advantage of my propulsion or my powertrain system running more smoothly and itself causing less inherent power losses. So the same is again true with the power density of the HVAC system. So by having higher power, I can again use that additional space and the prevented power losses in favor of my battery, and by that reduce the potential required cycles of recharging my battery, which again has a positive impact on the lifetime perspective. So thinking of automotive, this is pretty much what we have as a first basis, mixing up mild hybrids and modernized vehicles. We, of course, think that these portions can certainly merge. So we are thinking in a way that 48-volt systems can be used in all different kinds of vehicles. It could be used not only and others. It's really independent of what powertrain system you want to have. Just thinking of higher automated vehicles, we have a huge potential for technical innovation and for technical improvement in modern vehicles in the future. Gloria, is it the same in industrial context?
Yes. So for the next topic, we're going to talk about powering the AI revolution and how 48 volts can, improve the adoption of the AI revolution. So AI workloads, especially those that involve machine learning and deep learning, they require a very high performance computing resource that then requires high power. The adoption of 48 volts can improve the efficiency and increase the power density, all while saving space and allowing for faster cooling. So the efficiency of power conversion and distribution is crucial in data centers. As mentioned before, converting from a high voltage power to lower voltages results in energy losses, but a 48 volt system reduces that step down conversion loss compared to the 12 volt systems, for instance, which leads to an overall improved energy efficiency. And this is particularly important in AI data centers where the power consumption is already very high. So because the 48 volt power distribution can handle higher power densities more efficiently, this means that there is less heat generated by those power losses, and which then reduces the cooling requirements and overall saves energy. As mentioned before, 48 volt systems can deliver more power through smaller and fewer cables compared to the lower voltage systems. So the overall reduction in cabling here as well required for power distribution within racks frees up the physical space for any additional hardware. And then last but not least, with the rise of AI, the design and size of the cooling fans have been significantly impacted. To dissipate heat more effectively, data centers need more robust cooling solutions, which often resulted in larger or more powerful fans. And 48 volts, because of its high power, allows for the design of more powerful fans to move more air or liquid to improve the overall cooling efficiency. Next, I want to get into a little bit more of industrial applications that deal with factory automation. So 48 volt enhances the safety and efficiency of factory automation equipment, primarily by reducing electrical hazards, again, improving energy efficiency and enabling more compact and integrated system designs. So battery operated industrial robotics are on the rise as there is a growing need for more smaller and mobile tasks within factory floors. 48 volt systems enable a higher power density, allowing for a more compact and efficient power storage and delivery system. So again, the thinner and lighter cabling is a huge benefit in these mobile and portable equipment, such as AGVs, AMRs, and drones, where weights can be a very critical factor in the design of that system. So these compact and integrated designs really optimize the space utilization within a factory floor, and it also simplifies, the installation and maintenance process for these applications. Typically, within automation equipment used in a large-scale manufacturing process, they operate at very high voltages. So as mentioned before, this depends on the region, but here in North America, it's 120 volts AC. In Europe, it's 230 volts AC. But 48 volt DC is obviously a more safer way to handle these applications compared to these high voltage AC systems, which again reduces the risk of electrical shock. And it's very critical for equipment such as collaborative robots or cobots, which work alongside humans. Last thing to mention here is that motors powered by 48 volts can achieve higher torque and rotational speeds. So this makes them very suitable for industrial or factory automation equipment that require rapid movements or heavy loads.
I think there's a couple of interesting things come to mind here. In cooling, I mean, the efficiency of a data center power supply is in the high 90s, right? I mean, it's going higher and higher. But when you're talking hyperscale data centers, even 5% wasted as heat is an awful lot of heat you have to get rid of. So anything that a designer can do that will reduce the power losses is going to be critical. I mean, we've all read stories recently about Microsoft, burying data centers under the bottom of the ocean. I've read stories about Google using an old sawmill for data center because it has cold water coming in from a bay in Finland to provide cooling. It's a key issue, I think. And the other thing that I've noticed is in the industrial space, many of these higher power applications are also in space-constrained environments, which means it's that much more difficult to get the heat out of the equipment. And once again, moving to a higher bus voltage is going to yield benefits in terms of generating less heat through resistive losses and therefore making it a lot easier to cram more power equipment into a smaller space. And finally, I think that AI, you mentioned earlier, I think it's interesting now, we don't only have to worry about AI in the data centers, we have to worry about AI at the edge, because a lot of those AI functions are now migrating out to the edge, which again increases the power that has to be is generated and has to be gotten rid of, in these smaller space-constrained applications. So that's very interesting. So thank you. So I guess this is an Allegro presentation. I mean, so next question I have is, tell us about Allegro and your solutions for 48 volts, and why should customers consider Allegro in their 48 volt designs? Who would like to take that one?
I'll take that one, Paul. So let me give a quick introduction. If you move on to the next slide, what you'll see is that, Allegro is a leading sensing and power IC solution company. So we've been around for more than 100 years. Have been developing sensors for many years, which is one of our key products, and have expanded our offering in the power IC space with motor drivers, gate drivers, isolated gate drivers, a lot of different products that have been very critical. And we are an automotive first company, so we've designed a lot of products for the automotive, reliability and quality requirements. And we have been expanding those products into the industrial space. So you can see that about 73% of our revenues come from automotive. So we are an automotive first company, but we haven't stopped there. We've been expanding those products. We have found home for those products a lot in industrial and a few other segments, some consumer products, but industrial is fast expanding for us. And, on top of that, the key thing is that right, we have been innovating on these products. So one of the key things that we have done, which we're talking about today, is that we saw this coming. We have developed our process technology and capabilities to support this, expansion in the market, which I'll cover next. So you can see why Allegro for 48, right? Beyond being a very well-established and reliable company, we have technology and products that really address the needs of this expanding and new growing market. So we have a technology, on the right side, you can see all the different technologies we've had over the last few years. We've had it way before that, but you will see over the last 10 years what we have done. So basically around 2017, 2018, we brought about our latest process node, which allows us to do 110 volt, up to 110 volt transistors on the system. And so what we have done with that is the advantage of that is that we have a high voltage process node that allows us to bring in precision analog and magnetic transducers on silicon, as well as high voltage gate drive circuits, all on the same process node. So basically what we have done is we have brought together a process that addresses the needs of the market. And some of these products are already in use, and you'll hear about that in the next couple of slides. You'll hear about what kind of products we have already in the market and addressing some of these requirements that Carsten and Gloria have been talking about in terms of efficiency, higher power density, and more power to drive higher performance. And The best part is that the products, sorry, you had a question there, Paul?
Well, I'm just looking at your slide here. I mean, those of us who aren't semiconductor designers, I mean, 110 volts, why is 110 volts process technology for a 48 volt system? That seems a little bit of an overkill. But is there a reason behind that?
Well, we have built products that can support higher than that if you need it. So we have got products today that are 80 volt, and you need margins of error for all of this. So we have designed the process to be able to handle higher voltages if needed. But that safety level that I talked about earlier prevents most systems from going beyond 60. But our products are designed beyond that. So we are designing already at 80 volts. We can go up to 90 or 100 volt products. But we got to keep a good balance of how far we go for cost efficiency, because the product can get more expensive as you go up in voltage. So you got to be very careful in that. So we're trying to bring a good balance in that. But the process is capable of handling higher. And the main reason that the higher voltage driven is really from gate drivers, where you got to drive. We need those high power electronics. Okay.
Okay.
So
Thank
the
you.
other advantage is the second point that I've highlighted there. Really, our products are designed. So let's say we've designed a product for maybe 60 or 80 volts. The good thing is that if you have systems today running at 12 volt and you're transitioning to 48 later on, the same component can be used to support it at 12 and 48. So we give you that transition point and very minimal design changes, which may be around the other components on the board. That's the advantage. Our portfolio is very broad, and a lot of our products are already 48 volt capable. For example, our current sensors can run at 48 volts in systems for in-phase current sensing. And then the next point. Sorry, go ahead.
Isn't it current sensors running at 48 volts? I mean, I always thought a lot of these current sensors run at much lower voltages. Is 48 volts significant in that?
Well, it's the supply voltage is lower. You're bringing a very good point, which I think Andrea will touch on in a few minutes. So there is what is called 48 volt supply capable and what is called 48 volt system capable. We'll hold that point for a minute. Andrea will cover that. So current sensors, to just quickly answer your question, the supply voltage is lower, but it is capable of doing in-phase current sensing at higher voltages in the system. That's what it's capable of, because it's designed with this higher process node, higher voltage process node.
Thank you. Thank you.
Okay. And another point, just to answer, you see 110 volt. Actually, the transistors breakdown voltage is even higher. It's about 122. There's even more margin built in for this process. And we also have another, few other advantages within the process. It's much lower, drain to source resistance, which actually improves the performance of the product. It allows for negative transients. So there's a lot of things that we have put in our proprietary process that allows us to support these higher voltage products.
Okay. One final thing. This is an interesting slide. I hear a lot about the specific requirements that pertain to automotive that are much more stringent than even in industrial fields. This ISO 26262 is something that I've been hearing a lot about in recent years. Can you briefly talk about why that's important, meeting that standard?
Yep. So I think because safety, we have talked about it quite a bit, is very, very important, right? But within safety, what happens is anywhere humans are involved, we got to be safe. And automotive products require a development process as well as product capabilities that meet certain standards. That's where the ISO 26262 comes in. So Allegro products are designed with ISO 26262 in mind. So the whole development process is safety certified. And then on top of that, the products themselves have features, what we call for diagnostics purposes. So, it has many different diagnostics depending on the product that can be utilized by the end customers or the customers who are designing these systems, a braking system or a steering system, where the safety requirements are even higher with autonomous driving coming up. So we built in features like there is dual chip in a single package. So you got a redundancy built in. So you have one primary and a secondary doing the same function. If one fails, the other can take over, or you can hand over and notify the system so that there is safety safety guards in place. And then also the diagnostics help, because when something goes wrong, the fault diagnostics can trigger signals that will communicate to the main controller in a car to take preventive action or hand over manual control to the driver so that a failed system is not still operating. So it's a very, very important feature. And there is an equivalent safety standard for industrial as well. which gets covered by us covering these automotive standards.
Okay. It almost sounds like automotive design just starting to get closer to what we're used to in aircraft, where we have dual systems for everything, and there's never a single point of failure which will cause the car to stop. Okay, that's very interesting. Right. Thank you.
Yeah. And the last point is right. We're going to continue to innovate. That's what Allegro has been doing for many years, and we'll continue to push this envelope with regards to 48 volt and what can be done within that. Okay.
Thank you.
I think next, Andrea.
Yeah,
if you want to go
here.
A little bit.
Okay. Yeah, thanks for the very good introduction. As Rama pointed out, Allegro has quite a broad portfolio of a product for 48 volt system. Here, for example, I would like to give you a snapshot of the most popular product for this type of application and for 48 volt system. We can see here in black product already in production, it's mass production on 48 volt system, and in blue product that will be released in the coming month, but this fiscal year. Now, let's take an example, for example, 49100. So 49100 is a gated driver for 48 volt system. It integrated a current sensor and a buck converter in a single device. And this has been designed specifically for 48 volt system. And the reason why it's difficult, because in a single device, we handle both high voltage capability, like a 48, but we need also to process signal like a current sensing or SPI communication. And we needed to step down from 48 to 12 volt. And internally in this device, we integrated really an efficient buck converter. So we can create a solution that is ready to use. And this device, for example, can operate up to 80 volt without any problem. And as Rana was pointed out before, this is very critical in an automotive environment, because the battery is normally 48 volt, but the device needed to operate up to 60 volt in normal, fully operational, fully in spec, with a transit up to 70 volt. But to operate at 70 volt, a lot of time we have internal node that go much higher. And this is why we need a high voltage processor, because we need to protect not only the external pin, but also the internal node. And to be efficient in the switching and the commutation, we needed to raise the voltage higher than the operating voltage the majority of the time. And this product has been designed for APS EMB system, as Ram was saying, and so this is a safety critical environment. This means that this has been developed according to the ISO 26262. And really, we are leveraging all the experience that we did in the last 20 years in Allegro in automotive on 12, and we apply right now on the 48 volt system. And this device is available today because many years ago, we started to understand the advantage of 48 volt. We understood that there was a clear trend moving to 48 volt system, and we wanted to be ready when the transition will happen. And we are now in this transition phase. And this is why today we can offer a good portfolio of product. Now, when we are talking about the 48 volt system, we should forget that not all components will run at the 48 volt system, but we still have some components that doesn't require high current, that are best optimized in terms of cost for 12 volt system. For this reason, for example, we have a device like the 81815 that is a simply buck converter that can step down from 48 volt to 12 volt. Because in every 48 volt system, all the time you needed to step down to supply a sensor, for example, like we see later on a current sensor, it can be angular sensor, it can be only the digital. And the way that we can step down from 48 to 12 needed to be done in an efficient way. And this is why technique like a buck converter are normally used for this type of product. But there is also a challenge doing this type of things. One is, of course, the high voltage, as we already explained. The other is we wanted to minimize the BOM. We needed to really optimize the real estate of the system. And this is where the innovation from Allegro step in. For example, this device here is able to switch to operate at a switching frequency around 2.2 megahertz. So this means that we can reduce the external coil of factor between 5 and 10. And This means that it's not only the single IC, but it's really the system optimization that Allego is looking for. And this is part of the innovation that Allego is having. And this is what we are introducing. So when we discuss and we define a product for 48-volt system, we are not thinking only to the IC, but we are thinking about the system and how the system can be optimized for 48-volt system. Now, this is to give you an idea about automotive and what we are doing today. And if we go on the next slide, let's
Before we do that,
yeah,
I have a quick question. So on the last slide, you talked about the 5 times better EMI performance. Why is that an important point to mention in the automotive environment?
Yeah, so increasing the switching frequency on the buck converter allows to reduce the inductance. And this is quite critical. So, and this is why having also, this device has also integrated boot and bypass capacitance. So this means that we can be better in terms of EMI, for example. So really, we are integrating components like external bypass cap. We are trying to minimize the connection between, the length of connection between inductance and the device. We are also increasing the frequency to reduce the external inductance. And everything of these elements are critical for 48-volt system and in general in electronic, because EMI, EMC, it's really the concern. When everything is switching and now you have a lot of more power calculation, you need more power, you want to minimize really the electrical noise that you are generating, and you need also to be immune from external perturbance. And this is where Allego spend quite some time in developing a dedicated product.
Okay, all right, thank you.
You're welcome. Now, when we talk about the 48-volt system, I think that everybody agree that we are talking about efficiency, we're talking about extend battery life of your car, and it really means optimization of power and the current. But this means that we need to be able to measure the current that is used in the server, for example, or in an electric car, or in recharging or onboard charging. And Allego is leading worldwide in the magnetic sensor and the current sensor. So we used our background and all know-how in order to define a dedicated product for current sensing for a 48-volt system. Here, for example, I have a few part numbers, as you can see here, where we can measure the current to an integrated primary conductor that can be, for example, at the 48 volt or 100 volt. And the galvanic isolated, we can measure the magnetic field that is generated to extract the current. Now, it's important to observe that this simply device is really competitive against shunt, because we can fit, for example, a small package like a 4x4. But there is also another advantage. We can sense current with a resistance of 100 micro-ohm. So this is extremely low impedance, and it's extremely lower than what you normally achieve with shunt, assuming that you wanted to have the same resolution accuracy. And in Allego, we can do all this in an integrated package, and we can measure current up to 200 amp. So depending on the application, if we are talking about a server, if we are talking about onboard charger, we are talking about electric vehicle, we have a dedicated product to covering the different requirements. And for specific application like other system, also the current sensors being developed according to functional safety, like ASIL, for example, in order to be used in, let's say, tough environment. Now, this current sensor is really leveraging the galvanic isolation between the primary conductor and the magnetic sensor. But in Allego, we are not stopping only on the current sensing when we are talking about the galvanic isolation. But in the recent year, we developed a new product that use isolated, it's called isolated gate driver, that allows us to drive external GaN and the silicon carbide. So this is really the future when we are talking about high power. And in this case, we are talking about a 48-volt system, but also higher voltage. And this type of device that we developed in Allego has a unique feature, like for example, inside the single package of device, we are able to transmit power and signal to the gated driver, the GAN gated driver. And this is a unique solution on the market that allow you to reduce the BOM, minimize the real space of your PCB board and on the system. And at the end, you have also, because it's fully integrated, really every parasitic capacitance due to common mode, for example, are completely minimized. And this is an example of innovation that we are applying in Allego. And this is coming from 48 volt system and is going to 400, 800 volt, for example, for battery. Or when we are talking about solar panel, for example, we are going to 1.2 and more, 1.2 kilovolt and more.
Okay. So you're done with that, Andrea? Anything on isolated gate drivers?
Really a general overview of the type of product that we are doing in Allego. And as you can see, we are covering all the full system. So we are going from gated driver for PMIC to current sensing and so on. So we are really addressing all the products that are running under 48 volt. And for each of them, we are providing a dedicated solution.
Yeah, and actually one more point, that's a good point you mentioned. On current sensors, there is actually even more products. We have listed some of the examples here, but there are other products that are 48 volt system capable. And so the portfolio is pretty broad that people can use. And once again, I wanted to highlight they can be used for 12 and 48 volt systems. If it's designed for 48, you can start using them in 12 and 24 as well, and allow you to transition to 48 volt whenever you're ready for that. So pretty flexible in terms of the product. Okay, so Paul, back to you.
Yeah, I noticed that I see that the magic word SiC and GaN on this slide. And, you know, clearly SiC and GaN are making having big impact on the whole power design ecosystem. And it's good to see that you are accommodating that with these isolated SiC and GaN drivers too. And of course, SiC is replacing IGBTs in pretty much is the future, and certainly in terms of traction motors. So that's an interesting thing that you're keeping up with trends there.
Yeah,
okay.
We are really monitoring all the major trends, and we can clearly see the advantage on isolation, GaN, 48 volt system, and the higher voltage.
Yes.
Yeah, I think we can touch on that right next is really clearly what Paul brought up is really what's the future trends and how we are preparing for it. So I think, Carson, you want to take first on automotive, just give a few thoughts on where we see in 48 volt and where you see it's going to be used. And then I think Gloria can take the others.
Absolutely, Ram. Thank you. So for automotive, as I've spoken about it a little bit, there's definitely a huge potential for 48 volt applications and for the whole voltage level within the vehicle, not only when we're thinking of electrification of the vehicle in a powertrain context, but also in thinking of more modern and autonomous and automated vehicles in safety aspects for applications or subsystems like steering and braking, but also in terms of efficiency improvements for example, thermal management systems. And basically everything that we win in terms of weight, size, or just overall efficiency improvements, that can be additional kilometers and extends your range, prevents your battery from aging, and preserves your vehicle by also making it more powerful at the same time.
Gloria, you want to talk something like what's the trends you see in automation and clean energy?
Yeah, definitely. So the future of 48 volts in industrial automation is trending towards greater adoption. As mentioned before, this is due to the ability to efficiently power advanced high demand applications while enhancing that safety and reliability and also scalability of those automation systems. And then to touch on clean energy really quickly, the future for this in 48 volts is also very promising. It supports more efficient energy storage systems and distribution systems while enhancing the integration of renewable energy sources and improving the sustainability of the energy infrastructure. And then I think, Andrea, the last one.
Yeah, the last is data center. So really the trend is going to increase the frequency, increase the voltage in order to increase the speed and the cooling capability of the system. As people are aware, when the limitation of the maximum speed is linked to the voltage, so increasing the voltage allows us to increase also the power and the speed that is used to cooling down. And this is a clear trend in the data center that we see. And when we are talking about the data center, we see the trend both on high cooling system, but also on the liquid cooling, like water cooling. So both apply to 48 volt system. And this is why, for example, for water cooling or the liquid cooling 48, it's really the nice spot, because going a higher voltage imply some safety protection that, of course, had more cost. Where instead, if we stay to 48, as Rana was explaining before, the maximum voltage that we can support without put the people in danger is a 60 volt. So it's really the nice spot to optimize the performance without require additional protection and safety in the system.
Yeah, I think one more point on that, Andrea, I'll add, which we I think touched on earlier on data centers, is in addition to the thermal management, which is the cooling, there's also the benefit, the power density and the higher power throughput allows you to have smaller power supply or smaller power distribution, or the same space but with more power, which allows them to drive the higher demand that AI is going to put on those servers. So either you could have more space for more servers, processing cards, or you would have more power available in the same space to drive the higher power requirements from those AI-based systems. So I think you benefit on the power side as well in terms of being able to support the higher demand coming from AI in terms of processing and the power needed to support that processing.
Yeah, correct. This is a valid point, and it's really why 48 volt is very critical for this type of application. This is why right now there is a clear trend to go to 48 volt system. It's a nice spot to be. It's improve, it's maximize the performance, maximize the power that you can deliver in a safety environment.
Awesome. Thank you. So let me close the session with just a summary real quickly. So Paul, and then I'll hand off to you. Real quickly, I just wanted to highlight, so what we really covered is the future seems to be moving towards 48 volt. We see it across multiple market segments and applications as we discussed. And the benefits are very clear. The improved efficiency, the higher power density allowing you more performance, and the higher power allowing you to have save cost and save space. So there's a lot of different benefits that comes from moving to this higher voltage, and we can see it. And you can see that the Allegro really is in a good position to support you in design of these products. We have the process node and technology that allows us to build products that we've already been building, with many of them in production already and many more coming. That's going to help you to take advantage of this new voltage system that will allow you to do a lot more innovation in your end products. And with that, I would like to hand it off to Paul. Thank you to Andrea, Carsten, and Gloria for helping us go through this material.
Thanks, Ron. This has been very interesting. We have a few questions in the Q&A box, and okay. I'll just start out with is one about data centers. Is 380 volts DC used or planning to be used in the data centers? In other words, increasing considerably beyond what we're seeing today?
Interesting. If it's going to be battery supplied, if they're using batteries in a data server, then the higher voltage makes sense, just like cars going to 400, 800 and higher capacity batteries. Andrea, do you have any thoughts on that? I don't know about this specific question.
I see server at 380 volt DC, so I confirm that this is used in data center. But we need to understand, at least we need to discuss a little more about the power distribution. So as an electric vehicle, for example, we are running at 400, 800 volt. Similarly, on the data center, we have a line at around 80, and after we go step down at 48, and after to the processor to 1.2. So clearly there is a similar trend than I see.
Okay, so it's probably, is it the backup battery technology? That's what's the higher voltage, and then you need to step it down to 48 and then use it across the systems.
Correct.
Okay.
And normally on the rack, they are normally running at the 48 volt system because this is where you can do the hot swap, for example.
I think this battery backup is becoming an increasing feature of multiple things. I mean, every green energy installation needs to have battery backup for when the wind doesn't blow and the sun doesn't shine. And certainly EV infrastructure, charging stations are now incorporating battery backup so that they can take advantage of when electricity costs are cheap, charge the battery, and then, so I think 48 volts is probably going to see many more areas where it's going to start taking over, because efficiency is always important in all of those applications. So
you're right.
Okay,
instead of trying to break it, sorry, I was just going to say, the storage, that's why the car battery, like Carsten mentioned earlier, going higher than 800, because in the same space you can store more power. Higher the voltage, more power can be stored in the same amount of battery space, and that's what's driving that higher voltage. So same could be possible in data center. Yeah, but the electronics have to operate at a much lower voltage, which is what the 48 volt makes a good operating point for that.
Okay, great. Another question. What innovations are necessary to adapt 48 volt technology for use in high load and high stress applications? Is anything specific needed to accommodate those?
Yeah, it's not an easy question. So right now, I think that the 48 is quite established type of application. We can clearly see in automotive. 48 volt is also used that will be applied also for truck and light vehicle, for example. Now, to have a device of 48, the limitation today that I see, it's more, semiconductor I see available, because today, Lego has a quite a broad portfolio of IC for 48, but when I look at the complete market of a semiconductor, there are not many suppliers that offer 48 volt. So as soon as this device becomes more and more popular, 48 volt, in my opinion, will be more adapted. But I don't see particular problem of scaling or stress or current if you have the right technology. And as Rama was saying, right now in Lego, we have the right technology, so we don't have a problem to over this type of product.
Yeah, and I think I would just add to that, right? Once again, at the electronic level, it's going to be 48 volt. You'll have to use the same volt, maybe with a higher current, to drive those commercial vehicles compared to a regular vehicle, because again, it depends on the kilowatt hour and what they need in terms of power to drive those vehicles, drive those motors. So that's going to be the thing. So, but at the electronic level, you are going to be at 48 volts, like mentioned before. It would make more sense to me for commercial vehicles to go down the 48 volt path sooner than later. Yeah.
And Ram, if I can add, when we are talking about the kilowatt of power, I think that the high voltage, 400 volt, 800 voltage is the dominant application. When instead we are talking about the power below 1 kilowatt, for example, 48 volt becomes much more interesting, because you don't have the overcost of the isolation, and you can really leveraging all of the 48 volt benefit. Instead, when you really talk about the traction motor, for example, traction, it's really 800 volt as we see today.
Yep, directly from that. Yep, okay.
Yeah, that was actually the third question was actually about scaling 48 volt systems to meet the power demands of trucks, buses, and other commercial vehicles, which you've already answered. And I'm assuming the same design constraints and capabilities would also work in other things. I mean, they're talking about electric locomotives now, for example, battery powered locomotives. So I think even in those areas, these higher voltage will have all the same benefits of reduced losses and reduced weight. And of course, in reduced weight, I think is key in any transportation application, because that that translates directly into increased battery life and increased range, which, as we know, is a big concern of consumers of electric vehicles. Range anxiety, they call it. So, okay, well, that's great. I think that wraps us up here. Now, just as a reminder, if anybody has questions after viewing the video again that come to mind, please feel free to enter them into the chat and the question box. And as I said earlier, we will get answers back to you as soon as possible via an email. So again, I thank you for allowing me to be the moderator on this talk. And unless there's anything else, Ram, would you like to have a final word?
Thank you, Paul, for moderating, and thank you for all the presenters, Karsten, Gloria, and Andrea, in covering the key points. Thank you to the audience. Thank you very much for joining us. And if you have any questions, please reach out to us through allegromicro.com. There is a request for information, or download this presentation and reach out to us with any questions. We'll be happy to help answer and support you going forward. Thank you.
Okay, great. Have a great day, everyone.
Yeah. Thank you, Paul. Thank you, Ram. Thank you to everybody.
Thank you.